Hello and welcome to the Game Feel lecture. We're in standing desk mode. We're staying energetic despite my lack of sleep, but that doesn't matter. Let's make some juicy video games. So let's talk game feel. What makes video games feel good? Hold on, where am I? Hello, there I am. All right. So I got my little lecture set up for game feel. Let's go into it. I made this in Unity. So what makes a video game feel good to play? What gives it that special sauce, that juice? I love the word juice, that quality where when you're playing with it, it tingles. It feels energetic. It puts you in that state of mind where you're like, like that good drum fill or that good jazz melody where you're just nodding your head along. What's that feel? Already you can tell it's complicated because I've just given you nonsense metaphors, definitions so far. But more so, ways that we make one type of game or one sort of game feel good won't work on another sort of game. So it's really something that's situational that we need to tease out, which means that we're out of luck. No, it doesn't. If we go back to the game design process, fundamentally, as a developer, we're going to try something, make a change to our game, test it. Does it feel any good? If it works, if it does feel good, then we keep it or we keep changing. So what we need is some kind of insight, some kind of ability to say, like, what sorts of things should I try while I'm working towards game feel? What are those insights? How can I think about the project in front of me and what types of decisions can I make? I can't just keep trying random things. Maybe eventually we'll end up somewhere interesting. Probably not. These are lenses, to use the Jesse Schell art of game design terminology. So back to basics. What makes a video game feel good to play? What gives us developers that intuition onto what makes a video game feel to play? Lenses, in Jesse Schell's terms, the models, frameworks, analytical tools, rubrics, these are all kind of mean the same thing. They are all descriptions of a problem. Can we describe the game in a way that will help us suggest changes that change the game feel? So do we have ways to describe the game? Okay, haven't gotten to game feel yet, but let's get into it. So instead of covering game feel, I'm going to give us some mental models, some of those descriptions for games that will help us think about them. And that's actually what we're doing here. So these are 6 unrelated, disconnected mental models for thinking about games. Number 1, flow. Ooh, we love flow. We're stealing this term from psychology, but it's widely used in game design. I won't spend too long on it because there are many excellent resources talking about game flow and getting the user into flow state when they're in the zone, when they're locked in. But this is the type of graph that you're going to see a lot when it comes to game flow. User flow, where the skill set, the ability that the user has, let's put that on the x-axis, and the difficulty, the challenge of the game, let's put that on the y, is when those two things are well equated to each other. When the user has a challenge, fate that they've been faced with, and the skill set to tackle it that match, that is what we need to get into flow state. I don't think this is like the best definition. You'll see this everywhere. I don't think it's the best because it doesn't so much as define what flow state is as define what it isn't. It tells us that in this bottom right section, when I have lots of skills but not a lot of challenge, it's probably too easy, or there's something boring or something unengaging. And then up here in this top left section, too hectic, too challenging, too difficult, too confusing. And we don't have that alignment. So it helps us tell us what things aren't in flow, and then we sort of can go away from those to get to flow. But like, what is this magical y equals x middle line area? Hard to say. Tetris is perhaps the pinnacle of flow state games. Tetris Effect for VR headset when you're really locked in, but let's just say Tetris. This is a game that is an absolute flow state machine. The challenge is so adaptive to your ability, and you can really push yourself to go faster. If you haven't found yourself ever locked into a Tetris game, and give it a try. Get that Tetris Effect. Close your eyes and watch the blocks fall. It's It's a fun place to be. Beat Saber, also a game that is very good at getting into flow state. Using that proprioception, using that like kinesthetic motion of your body, and like the rhythm and music. Those are both things that are like, coming out of dance, coming out of music, both things that are well equipped to get us into flow state. Putting that together, what a great game. So how do we get into it? That's, good luck. That is the end of this lecture point right now. But let's pay attention to how difficult things are, how engaging things are, how challenging, how confusing, how we control that over time in our projects. Okay, moving on to the next mental model, control action information. I don't have a good quippy name for this one, but control action information map is usually what I call it. So controls, actions, information, and the information are 3 ways to describe elements. So let's just, why do these look so different? Doesn't matter. Controls are the interface that you touch, the game controller, the controller, the buttons, the things that are on screen, the things that you're actually using and doing. The verb is the thing that you are doing in your head, right? The control is a button that gets pressed by the thumb. Jump is a thing that I say in my brain. I'm going to jump. And then the control does it. Information is what is communicating about that. So when to jump, how to jump, or what the jump button is. The character's animation of jumping might be part of that. Their position on the screen moving would be part of that. To make our games feel good, we want to make sure we are mapping appropriately between control and action and information and control. When they don't line up, we have a problem. This happens all the time, and it's very easy to make one change and like tweak one thing, but then you're not tweaking something else. And through an iterative process, we can really easily lose these connections. So it's something to really back up and analyze your project with. So let's look at a game as an example. Dino Jump, the infinite running game where you move around. And I want to make it juicier, so I might do my initial first guess for juice, which is adding animations and adding particles. Now the dino sort of squishes, has a squash effect, and when they land, animations go. And I'm playing it, and the game isn't any more fun than it was. This didn't work, but those are the juicy things. Particles are game feel. Why isn't it working? So let's back up and use control action information maps to figure it out. My controls are a single impulsive press. That first moment I press down the jump button. Whether or not I hold it down doesn't matter. And there's no directional input. The action is jumping, but that's not the only action. I'm also looking at the approaching obstacles, and really this has become a timing game and a consistent rhythm game. The information I have that I'm looking at is when I'm landing the particles, when I'm jumping that squash, as we mentioned, we just added those, but I'm really just paying attention to how far away the cactus and the dinosaur are. That is like the main thing that I'm caring about. If I were to get rid of everything else and actually just simplify this game to the approaching cactus and the dinosaur jumping, this is what I'm left with, is I'm watching a progress bar and deciding when to press a button. So the information I've been given and the action that I'm doing aren't matching up. So how can we fix that? Well, if we can change one to be the other, or the other to be one, we can change the information, or we can change the action. Well, we know it's the Dino Jump game, so we're not going to change the action. So let's change the information. In this case, let's add more information that matches what I'm actually doing, timing. So if I'm watching these cactuses approach, I can add other elements in the scene that are also approaching that can give me visual reference. And something to compare to. I can get some parallax, I can get little grass on the ground, more things that move with the cacti and help me figure that out. And the other action is I have memorized something. I'm not actually timing based on my visuals, I'm timing based on, once I get that boop, 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 boop. Once I get that rhythm down, that's all I'm doing. So in this case, there are lots of games for memorizing those rhythm, those patterns. I already mentioned Beat Saber, which one is this? I forget. Oh, don't yell at me in the comments. Just let it go. Jump Boy. I don't remember the name of that game. That was too new for me. I was a Bit Trip Runner player back in the day. Fine. So the rhythm is one way to go. We can embrace it and really make it this musical element, or we can get rid of it, which is what we're going to do. We're going to randomly vary the cactus spawn time, and then that's going to get rid of my ability to memorize the rhythm. And now my information is no longer memorizing rhythm, so I must now be staring at the cactus. My height of my dino changed? Doesn't matter. And we got the visual elements going by, much juicier. Okay, that's model number 2. Let's move on to the next one. Decision frequency. Decision frequency is one of my favorite and most used mental models for how I think about video games and game feel. Short, medium, long. Short, medium, long. Reflexive could perhaps be another one, but I'm just going to keep it simple because what short, medium, and long mean depends on what game we have. But how far ahead do I need to think in order to make a decision? How future oriented am I, and how much of the past am I paying attention to? So do I have a long-term decision where I'm strategizing 15 moves ahead, or a short term where I'm just like reacting to something? So like in chess, in the beginning of the game, in the opener, it's all short because you're just memorizing your openers. In the medium game, it's all long-term strategy, and then the end game kind of goes back to short as you run out of options, because I'm probably losing if we're playing chess. Oh, but Tetris is a game I'm probably not losing. Short-term decision-making, where can this block go? It fits there, let's put it there. Medium-term decision-making, I have a few places I can put this J block. I can put it in its current position, or I can put it like over here, maybe upright in this area. But I can look ahead. There's that, I got a hold queue coming up. I need this place where I can put the this block. I can swap out from the S, so I can think a little bit ahead and leave that opening for me as a backup plan. And I can go, okay, I'll put this here, and next I'll put that. So I'm always leaving a space for the next block. That's my medium term. Long term, we got T-spin cannon thin whole. We've been planning this for a couple of cycles of pieces, ready to drop some absolute damage onto our enemies, or get some points, as the case may be. It takes a lot more planning to get that one set up. A much more common example is first-person shooters. These are, I think, the gold standard when it comes to short, medium, long-term decisions. It's really hard not to make a fun first-person shooter, because like your right hand reflexes is like really, reflexive short-term decision. Your arrow key is moving around and dodging is like medium-term decisions. And then you've built a level and done storytelling. You have these varying layers of decision making baked into like every first person shooter. But yeah, so like aiming with the mouse would be my super short. It's me in a gunfight against one other person. How my team is choosing to attack the objective would be our medium, maybe long or medium term decisions. Okay, I'll use Google left, I'll flank right, and so on. Or enemies come in, let me duck under cover or not duck under cover. Those are less short decisions. And then in Counter-Strike, yeah. Which one is this? Doesn't matter. I'm not a CS player. You have the rounds, the multiple rounds. It said, it was so weird to say Counter-Strike Go instead of CSGO. You have the multiple rounds between each one, where you're saving up this currency and planning ahead. Am I gonna go all in to win a different round? So short, medium, long, and everything in between in most first-person shooters, especially multiplayer ones with multiple rounds that have some currency between them. Some games don't have overlapping short, medium, and long-term decisions. Flappy Bird has short, and that's it. You have this exact one distance ahead you need to think about, and that's it. You do not need to plan ahead in Flappy Bird whatsoever. So how could we maybe add some longer-term decisions to Flappy Bird? Often we'll pitch things like power-ups or so on, or risk-reward decisions where there's maybe a thinner pipe with more points or something. But like, what are those points for? How can we apply short, medium, and long-term decisions to that? And in the case of Flappy Bird, but in some more interesting games like Civilization, then perhaps we have some other options. We have maybe the most options to add short, medium, and long-term decisions to it. So that is decision frequency. I really like to think about musical frequencies or like audio frequencies and having lows, mids, and highs and all those layered together. And that's the same way I sort of mentally think about user decisions and how far ahead they're thinking, and about what different elements of the game they're thinking and what different parts of it. You play a platformer and you're it's kind of boring, or you're backtracking in a Metroidvania. You've already done this. The decision making has been done already. You solved the puzzle. You're just kind of executing. There are other ways we can play that out. Okay, next mental model is the interaction loop. This one we know. We've game designers. We've seen this before. Let's break it down into 4 parts with my very beautiful diagram. There are 2 halves of the coin here. We have the player here on the left. We have the system, the video game that we're making on the right. And things that I am inputting into the system, like my controls and my decisions, go into the system, and then it's going to react to me. It's going to move the player in response to what I do. And then I am going to receive that reaction and maybe make a new decision from it. I am going to dodge the enemy I can now see. And then the system is going to communicate to the player. It's going to give me information, and then I am going to react to that. So I am the driver, and then the system reacts, or the system is the driver and I react. And each of those has sort of 2 parts, right, as I've diagrammed, but we can really think that this is like multiple ping pongs bouncing back and forth, not just one ping pong ball going back and forth. On my table of interaction loop. So when I make an impulse, is there a reaction to it? And when the computer makes an impulse, when it gives me information, do I react to it? And can I react to it? So we want to make sure we're like respecting the player's agency. And when they do something, we want to give them feedback that, yes, you have done something. I am acknowledging that you've done it. Maybe it's the wrong thing, but something should happen, right? It's often you see players running up against the wall and it'll still play the movement animation. It's not because like games aren't good enough to just have the player be like, can't go that way. Let me just put a hand against the wall. It's because when I push the run button, it's better for me to see that player run than it is for the game to be like, that's not right. So when the player tries to do something, we need to acknowledge it. We need that error noise when it doesn't work. We need that, you move into a wall. I'm available for Foley work if you ever need some sound effects. You can just but we need to acknowledge what the player is trying to do, because if there's none of that, it's not going to feel like an interactive system if we don't have it. So like I already mentioned, invisible walls or running into walls already existent. When Mario hits the wall, they flatten, they squish, stars appear, blah, 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 blah. They sprinkle, they move, he bounces back, he makes a noise. There's a whole bunch of things happen. So squished. My slides are messed up. Unity is not PowerPoint. This is from Cyberpunk. When you're driving out of the map, just away from anywhere, where you would have some invisible wall that's the end barrier. Before you reach that, I think they just teleport you back. I don't remember. But before you reach that, you get this message on screen: turn back, nothing out here for you. So it's like in the character, in the world of the game, the user knows like, we're going to step out of in the diegetic. We're going to step out of the game world and just, hey, by the way, nothing doing. So it's nice to see those kinds of messages instead of just the blank wall. And then like when the system does something, let the player react. So I think the most common example for when the system does something and the player can't react is cutscenes, where I'm just watching a thing happen in front of me and I can't do anything about it. Or scripted events, or moments where I see something that feels interactable, but I can't interact with it. In VR, we're always like trying to knock stuff over, and there's no colliders or physics, so we're just like, whatever. That's very frustrating. Like you need to respond to me. You need to let me show this little thing having a little squish animation in VR, even if it's not actually doing anything. There's some games that use shaders and tricks to like just get shiny when your hand is near it, or get bubbly when your hand is near it. But yeah, too many cutscenes is maybe like the main example of the game presenting something to the player, but not respecting the player's agency or reaction to that. Okay, moving on from the interaction loop to the next one, feedback and juice. Our next one. Juice is a more catch-all, broad term. Feedback is specifically the part where the player is reacting to you and your decisions. So here I've got Peggle. Peggle is a game where you hit you don't hit anything, where you hit these spheres, and everyone that you hit will disappear, and your goal is and they give you points, and your goal is to clear the board. So it's sort of like a Plinko machine type of game. So I've made Peggle. This is a real, why am I making a presentation inside of Unity? It's because this is a video game. Peggle is boring. This game is boring. The reason I chose Peggle as the game to make here is because you press a button and then you kind of just watch. You don't get to do much. So it's a really difficult case for making a juicy game. So hopefully we'll explore some options. As we saw it, it wasn't just boring, it was confusing, which is even worse than boring, because you couldn't really tell what was going on. So we need to communicate the state of the game. State is the status of all of the elements in the game. We can't just tell the user what's going on, gotta show them. Stop at the heads-up displays and the text, just show me in the game. In my case, we're gonna add some colors because some of these pegs are worth more than others. The gold ones are worth 1,000 points and the blue ones are worth 100. I decided, but that, they disappear and now the state of them being gone is gone, but still not much happening. So the other state that we're exploring here is as I hit pegs, boop, 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 they change colors. I'm going to put a little dot on them, and now I know which ones I've already hit. The state of those pegs has changed. Let me reflect that in the UI. Let me update the state. All right. The next easiest way to add state that everyone always does, and maybe we should do less of, is just some text up on the top left corner. There it is. I'm going to get some points. So we can, we can do some entertaining Peggle action. And as I get points, you can see the score is increasing. Yay. And that did, in fact, give me 1,000 points. Yay. So that's communicating the current state of the game, but that's not very juicy. It's important for clarity and making the game fun, but we also need to communicate whenever that state changes. So we need to communicate what the state is, otherwise it's confusing and unreadable and hard, and we need to communicate when it updates or when it changes. So we can add animations that are reactive, where the every time I hit one of the pegs, pew, little transparent circle animates out, and I can see, a thing happened. We got a change in the state. Did I add sounds in this one yet? I don't remember. Sounds also help us do that. We get that animation there. There we go. Score pings. We love a score ping. I do have some sounds. And you can see the little text, the little numbers of how many points I'm getting are animating. And I'm not putting that animation up in the top left. I'm putting it right in front of you where you're looking and what we care about. I can't add up the score just by seeing a bunch of numbers, but I do have a good sense of how many points I'm getting. And yes, that orange one is worth more. I mean, I missed it, but let's pretend I didn't miss, and that one was in fact worth more. Yeah. Next, in the top left, this is a pretty easy one to implement. Instead of showing the text of the current score, I'm going to show this other number that I'm going to just keep in a script. And then whenever my actual score and my displayed score are different, I'm going to just add 10, add 15, add a little random number to it until they're the same. And then, and add a little bit of a time delay there. So what will happen is when they're different, it'll quickly update the score like that. Let me get some more points here. There we go. So you can see the number going, and then yeah. So kind of, and then at the end of the round, this number will go to 0 and this number will increase. And in my periphery, I can, it's not like I can really see those little intermediary numbers, but in my periphery, I can see them changing. And now I know, oh, I'm getting points. Something's happening. I have that feeling of it. Okay, so we can communicate the current state. We can communicate when that state is changing, and we can communicate the future state. Interesting. We need to give the player the ability to predict what the future state will be. And by predicting it, we're going to create some tension. We're going to create some anticipation of it playing out, and either they were right and it's correct, or they were wrong and there was maybe a surprise, maybe a joyful surprise, maybe a difficult surprise, maybe an oh no moment. But we're going to allow this player to constantly predict a little bit into the future or a lot and have different decision frequencies. And then relieve that suspense and let them see what happened. So here I will put a trail behind the ball. And by drawing the trajectory as an arc behind the ball and how far stretched out it is, I can see how fast it's going, and I can have a better sense of where it's, I can really just extrapolate that line really easily, because I'm like, it's moving in this way. Any screenshot of the game, I could start making predictions as opposed to having to watch the video, right? If I froze it without the trail, took a screenshot, I wouldn't know what direction the ball was going or how fast it was going. But with the trail, we can get some of that information, and that helps us make that mental analysis. Anything to make it easier. I'm not thinking about it, but that's the point. Is it's all just using my intuition. Yeah. Lights and shadows are very similar. As I'm just putting a little soft light around the ball, and then as it moves, more other things on screen are reacting to that movement. In this case, it's kind of subtle, but I'm casting a shadow, and those shadows are sweeping as the ball is changing its position. And that's really giving me a nice sense of where that ball is and how fast it's moving. It's not like I'm going to measure it with like a measuring tape against the screen. It's just that more of that information that is reactive to the things that I care about in a predictable way means more of my brain's ability to like intuitively encapsulate that information and make meaningful predictions. Next, instead of having to force the player to make predictions, we can just predict for them and then display that information. So I have an entire separate physics scene running Peggle at a, way faster than the current physics tick rate, and then using where it will actually bounce to draw a trail. And then I can just predict where the ball is going to go. And then that especially on that first shot, it makes things a lot easier. Whoops. Pew. Okay. So we can communicate the current state, we can communicate the changes in state, we communicate the future state. But now I want the thing to feel alive. That's kind of a different goal. Is I want it to feel like it's not, like it is capable of reacting to me and being something that I am interacting with, and not something that's like, if I leave and come back, it'll be the same, right? That's a kind of a bad definition. But like, what I want it to feel alive. Alive isn't a very useful term, but like, I want to fill it up with potential energy it's like bursting at the seams and ready to be interacted with. The Twinkie where you can see a little bit of the filling come out, and when you bite into that, you're going to get a delicious Twinkie bite. Okay, random variation is a really good way to add some life to any game. I randomly choose the start position of the bucket, which is that thing on the bottom, and we're going to start moving it, which is a thing probably should have done earlier, but there we go. Yeah. Let's put some motion in the level. Let's add some things that are moving and changing over time. With For Me, that'll make the game a bit more difficult, and that will mean that any moment of time is different and unique, and I have to think about that in my short, medium, and long-term decision making as well. So it kind of ties together. So yeah, adding a little bit of motion, even on things that don't matter, cars driving around in the background, some parallax, anything like that, always very helpful. Next, let's animate these. Let's begin, and our state is changing from we are not playing to we are now playing. So let's animate that entrance. So little bounce animation, and let's vary that. Let's add a little bit. This is maybe too much, but let's add a little bit of delay in that animation, and we can have things pop into place. Juicy, love it. Audio. I've already had a lot of the audio turned on accident, but you'll pardon me for having an engaging lecture. Nothing new that we haven't talked about already. This is just a new channel of information. So everything I've been saying up till now the examples have been visual, but the motivation behind the examples has not. And when you have multiple channels of information, visuals, audio, haptics, even separate layers of audio, like the world mesh versus the HUD versus particles, things like that. all these separate channels of information means that we can overlap things really effectively. Where something might be noisy and busy and confusing, adding it visually, maybe this other channel is totally clear and available for us to communicate information in and state changes in. Next, let's communicate the number of bounces with the, by increasing the pitch of the game. It's just and then now I have a sense of progression and that I'm doing better as the level goes on. To communicate that in the game, like with some multiplier of score, would be very busy, but the sound channel is free and pitch is absolutely not being used for anything else right now. There's no music. So totally available for us to use to just communicate more information that I can react to. All right. So that was game feel flow, control action information maps, decision frequency, interaction loop, and giving players agency, feedback, and juice. That's 5. Didn't I have say 6 earlier? Number 6. What do you think? Leave it in the comments. Class discussion time is why my number on my lecture was wrong. And what's another model that you use in your game design practice? Huh? You tell me. Why do I have to do all the lecturing around here? Okay, I just went back to my notes. It was prediction. It was player prediction and thinking about future oriented as its own separate section, but then I rolled it into the feedbacks part, so they got mushed. But all the content was there. Okay. Okay, bye.